Welcome to the Math Critique, where I take topics you might be struggling with and show you that you can do it because you already have. Today's topic will be focusing on building the unit circle. Let's dive in. Now, I don't normally like doing lessons like this. I prefer when the lesson explains why something works, not just a quick memory trick. In this case, I want to show you this. I'll post another video explaining why we use these angles and how the unit circle works. This one is just a quick and easy way to build it so you can use the unit circle to solve trig functions of special angles. Now, anytime I've ever taught trig, when I get to the unit circle, unit circle trig, that's day one. We take about 20 minutes, learn how to build the unit circle, and day two is the largest quiz of the year. Now, normally I have between 50 and 60 students, and I get about 1 to 2 points that are lost. That's total. Almost everybody gets 100%. The 1 or 2 points that are lost are normally because someone forgot something very simple. They forgot to write down pi, something like that. So let's dive into building the unit circle. Okay, so we're going to start off with the angles because the angles, once you have the angles, everything else ends up being much easier. Okay, so now we're going to do the angles. Again, we're going to do them in radians because radians make more sense on the unit circle. It's much easier to build a unit circle with radians. So to remember which radian angles we're going to be using, all you got to do is remember how to count down from 6. The only trick is you got to skip 5. Okay, so what do I mean by that? We're going to count down from 6. We're going to start off with 6. We're going to skip 5. We're going to go 4, 3, 2, 1. Okay, those are the angles. You just got to put pi over it. Okay, so pi over 6, pi over 4, pi over 3, pi over 2. Now, why did I count down from 6? Okay, now if you look carefully, okay, now each of these angles here some of them are smaller and some of them are bigger. Okay, so as you start here at the very beginning here, that's the angle there is 0, because one of the line segments that we use to build an angle is going to be the x-axis. So then the second angle that we get to, this first angle here, is going to be the smallest of the angles. Well, of these 5 angles here, the smallest one is pi over 6. Okay? So that smallest angle, that first angle, is going to be pi over 6. Okay, so once I get that, I'm going to use that same logic and I'm going to write out the other angles. Okay, I have pi over 4, I have pi over 3, and I have pi over 2. Now, pi over 1 is just pi. So we're going to get there in a minute. But you should remember, pi is half of a circle, so pi is going to be this angle right over here. We'll get to that. Now, to figure out the other angles, that usually throws people. But the reason why I like radians is because if I just draw a few extra lines, I know exactly which angle goes where. So if I start off at the pi over 3 here, and I draw a horizontal line going straight across, it's going to meet up with this angle here. That means this angle here is another pi over 3. Okay, I can do the same thing for these other lines. I can start at pi over 4, I can draw a horizontal line over, and that means that angle there is a pi over 4. I can do the same thing, start at a pi over 6, draw a horizontal line, and then where it meets is going to be another pi over 6. Now, I know what you're thinking right now is, yeah, but what about the numerator? Well, we're going to get there. Just at this point, it's one of these trust the process. Okay, so the next step, now like I said before, that angle right there is going to be pi, the one that gives you the half circle, okay, the 180 degrees, that's pi. Now, for these other angles, you're going to do the same thing, but now instead of drawing a horizontal line, I can draw a vertical line. If I draw a vertical line, there's another pi over 6. I can start off at the pi over 4 that's over in this second quadrant here, and I can draw another vertical line. That means that's another pi over 4. I can go over to this next angle up here, the pi over 3, draw a vertical line straight down. That means that's another pi over 3. Okay, I can do the same thing with this pi over 2. I go straight down and I get another pi over 2. I can do the same thing with the next pi over 3. Now I can do this either way. I'm going to go and do another horizontal line based on where I was. So pi over 3, I can draw another horizontal line over, and that means that's another pi over 3. Do the same thing with the next line over, pi over 4, and the next line over is pi over 6. Okay, so that's all of my angles. Now, if I want to, either way, it doesn't matter which way you want to go. If you want to start off in that first quadrant, you can draw a line straight down, and that's another pi over 3. Same thing with the pi over 4. Draw a line straight down. There's another pi over 4. The pi over 6. Draw a line straight down. There's another pi over 6. So you can do that either way. It doesn't matter which way you want to do that. I'm going to get rid of these lines because it's just kind of cluttering up the diagram. Okay, so where do we go from here? So from here, I apologize, there's 2 pi. I missed the 2 pi. 2 pi is a full circle. Okay, so where do we go from here? So again, I'm going to get rid of those lines because those lines are getting in the way. And now I'm going to get those numerators. Okay, now this is where I'm not really, I don't really love how I do this, but it really helps to be able to put this together. So what I'm going to do is each quadrant is going to have a different formula that goes along with it. Okay, so the first quadrant up here in the upper right, that is good to go. Those are all of the correct angles. For this second quadrant and third quadrant and fourth quadrant, I'm going to have different rules I want to follow. So for the second quadrant here, what I'm going to do is I'm going to take n minus 1. N is whatever the denominator is. So we'll see what that looks like in a minute. I want to get the formulas down. So this second quadrant, I'm going to do n minus 1. The third quadrant, I'm going to do n plus 1. And the fourth quadrant, I'm going to double it and then subtract 1. So 2n minus 1. Okay, so what does this all look like? So let's start up here. So in this quadrant, I'm going to take that denominator, I'm going to subtract 1, and that's the numerator. So 3 minus 1 is 2. Do the same thing here. 4 minus 1 is 3. 6 minus 1 is 5. And there we go. That second quadrant's now set. Let's go down to the third quadrant. N plus 1. So I'm going to take this denominator and I'm going to add 1. 6 plus 1 is 7. 4 plus 1 is 5. And 3 plus 1 is 4. So 7 pi over 6, 5 pi over 4, and 4 pi over 3. And those are my angles. Now, for this, for the one straight down, you can do this either way because it's right on the border between the third quadrant and the fourth quadrant. So I can take the pi over 2. I can either add 1 to it, so 2 plus 1 is 3, or I can take the denominator, I can double it and subtract 1. 2 times 2 is 4, minus 1 is 3. So either way, I get 3 pi over 2. The other way to do that is you can just count. Okay, here is the angle here is 0, and then I go up top, and that's 1 pi over 2, and then 2 pi over 2 is the same as pi, and then 3 pi over 2, and then my last, they're called cardinal directions. The last one would be 4 pi over 2, which reduces to 2 pi. Okay, so now let's get this fourth quadrant in. So I'm going to take the denominator, I'm going to double it, and I'm going to subtract 1. So 3 times 2 is 6. 6 minus 1 is 5. 4 times 2 is 8. 8 minus 1 is 7. And 6 times 2 is 12. 12 minus 1 is 11. So there's all of your angles. Okay, that's all the angles. You can go ahead and simplify, you can go ahead and build out the rest of the unit circle based off of those angles. Okay, so now let's go ahead and do points, okay? Now, just like with angles, we counted down from 6. Here, we're going to count from 0 to 4, okay? So let's go ahead and do that. 0, 1, 2, 3, 4. That's the hard part, is to remember to count to 4. Okay, from there, I'm going to get the points, I'm going to take each of these and I'm going to put them all over 2. And then I'm going to take the square root of each. Okay, now the reason I did that is because it just makes it easier to remember what the points are. But I mean, you would never really write down square root of 0 over 2 or square root of 1 over 2. So we're going to go through and simplify these. So to simplify these, square root of 0 is 0, over 2 is 0. Square root of 1 is 1, over 2 is a half. Square root of 2 over 2 can't simplify. Square root of 3 over 2 can't simplify. Square root of 4 is 2. 2 over 2 is 1. So all of your points are now 0, because square root of 0 over 2 gives me 0. Square root of 1 over 2 gives me a half. Square root of 2 over 2, square root of 3 over 2, and 1. And those are all of the coordinates you need for your points. Now, the thing that you have to remember here is what goes with what, okay? So what you have to remember is the first number goes with the last number, the second number goes with the second to last number, and then the middle number goes by itself. Okay, once you get that, then everything else makes sense. Okay, so let's start off with this first coordinate over here. Now remember, this is a unit circle, which means this is a circle radius 1. So that means this distance from the center, from the origin, if you go straight out, that's 1 unit. That means the x-coordinate here would be 1, and because 1 goes with 0, the y-coordinate has to be 0. Okay, now what I'm going to do is, just to make this easy on myself, I'm going to remember, okay, 1 is the biggest number in my set of values, in my set of coordinates. 1's the biggest number. So I'm going to move, since the next biggest x-coordinate would be this one here, I'm going to move just one number to the left here. I'm going to move one number smaller. So square root of 3 over 2 is going to be the x-coordinate, which means because square root of 3 over 2 goes with 1/2, that's square root of 3 over 2 1/2. Okay, let's do the same thing with the next one. So the next biggest number means the x-coordinate is square root of 2 over 2. And since square root of 2 over 2 goes by with itself, that means that next coordinate is going to be square root of 2 over 2, square root of 2 over 2. Then the next biggest number is going to be 1/2. So the x-coordinate will have to be 1/2. And 1/2 goes with square root of 3 over 2, which means the next coordinate is x is 1/2 and y is square root of 3 over 2. And for this last value, just like with the first one, okay, this point right here is 1 unit to the right of the center. So that means the point is 1, 0. If I go straight up, the point will be 0, 1. Okay, so I can keep doing this pattern all the way around the outside, okay, just looking at the x-coordinates. The biggest, the next biggest, the next biggest, the next biggest, and then the smallest. And I can keep up that pattern going around the rest of the unit circle. Or, just like I had in the last, when I was doing my angles, I said, okay, this first angle is pi over 6, so this angle is pi over 6, this angle is pi over 4, this angle is pi over 4, this is pi over 3, this is pi over 3. All of the pi over 3's have the same coordinates. All of the pi over 2's have the pi over 2's have the same coordinates. The pi over 3's, the pi over 4's, and the pi over 6's all have the same coordinates. The difference is it positive or negative? So since this angle here is a pi over 3, this angle here is a pi over 3, that means the coordinates are still going to be 1/2 square root of 3 over 2. 1/2 square root of 3 over 2. Now, why did I make that first coordinate negative? Because all x-coordinates to the left of the y-axis are negative. So that means this angle, this point has to be negative, because the x is negative in this quadrant. I'm going to go on to the next one. Since this is a pi over 4, that's square root of 2 over 2. This is a pi over 4, that's square root of 2 over 2. Again, the negative goes with the x because x is negative in this quadrant. Y is positive in this quadrant. Same thing with the pi over 6 angle here is square root of 3 over 2. Pi over 6 angle over here is square root of 3 over 2, 1/2. And the negative goes with the x. Okay, and then I can do the same thing for this other coordinate right here, pi. I'm going to use the same coordinate as I did over here with 0. I just have a negative. Okay, for the rest of these, it's all going to be the same for the third quadrant. Okay, if so this is a pi over 6, so this is a pi over 6, which means it's the same coordinates, but in this quadrant, x is negative and y is negative. So it's the same coordinates, square root of 3 over 2, 1/2. It's just both of them are negative. And you can do that for the rest of these angles, the rest of these coordinates. Pi over 4 is square root of 2 over 2, square root of 2 over 2. Pi over 4 is square root of 2 over 2, square root of 2 over 2. Same thing with the pi over 3 over here, okay? And then you get to this, the vertical angle right here, the 270 degrees, if you wanted to talk about it in degrees, or the 3 pi over 2, just 0, -1. Just like it's 0, 1 up here, it's 0, -1 down here. And then here are the rest of the coordinates. Here, the x is positive, but the y is negative. So I have the same coordinates, because it's still a pi over 3. That's just like the pi over 3 here, just like the pi over 3 up here, and the pi over 3 up here. They're all 1/2 square root of 3 over 2. This one is still 1/2 square root of 3 over 2, but I put in negative by the y because y is negative here. Next one, since this is pi over 4, this is pi over 4, that's square root of 2 over 2, square root of 2 over 2. Negative by the y. Pi over 6, square root of 3 over 2, 1/2, square root of 3 over 2, 1/2. Okay, so those are all the angles and all the points. Now this is just building out the unit circle. We can go over another, I'll do another video on how to use the unit circle, but this is just how to build out the unit circle. So if you need to build it, this is how you do it. If you have any questions, please let me know.